And let's write down the title. All right, so, excuse me. Yesterday, we did calculations involving balanced chemical equations that allowed us to determine the number of moles of a substance starting with the number of moles of another substance. And we had a special name for that particular thing that we used. Does anybody remember what that name was, that little calculation we did? The mole ratio. Excellent. So the mole ratio allows me to go from moles of one thing to moles of another. And all I got to do is set up that ratio, right? X over 3.5 equals 2 over 1, depending on what the substance was. And those numbers come from the coefficients, the big numbers, in our balanced chemical equations. Now, we already know that we can calculate other things from moles. We've practiced calculating entities from moles using Avogadro's number. Now, I said yesterday, entities are a cool thing that we can calculate. It's kind of neat to know that there's, something like 2.75 times 10 to the 24 water molecules in a glass of water. But that doesn't do us any help when it comes to measuring stuff like water. So grams is the useful unit. And we also have a way to convert grams to moles. We use the molar mass. That's in the other calculation that we do. So what we're going to do today is put together our mole ratio that we learned yesterday, along with our molar mass calculations that we did 2 days ago, and we're going to complete a more thorough calculation involving chemical reactions. Because it's nice to know how many moles you have, but if we actually go into the laboratory, I do not possess a scale that reads moles. I do not have a scale that I can put something on and it tells me how many moles of the substance there is. What does the scale read? What does the scale tell me? Grams. It tells me the mass. But if I know the molar mass, I can get the moles. So that's what we're going to do today. Today's lesson comes in 2 parts. The first one we're going to do is going to involve one molar mass calculation. One calculation that involves grams. In the second examples that I do, we're going to need 2 separate calculations that involves grams. So in the examples we're going to do right here, there's going to be a mole ratio calculation, and there's going to be a grams calculation. 2 separate calculations. In the second examples that I'm going to do, there will be 3 calculations. A grams calculation, a mole ratio calculation, and then another grams calculation. All right? So let's try the ones that only involve 2 calculations. Don't worry about the date. Now, don't write this down. When we're doing an experiment, we don't have a device that can directly measure moles. It is more convenient to measure mass using a balance. Therefore, we need to be able to change mass into moles or vice versa when doing an experiment. And I don't like the looks of this particular one because I like to use the units. I asked you to think about the units of molar mass. What are the units of molar mass? That's something that you really almost need to memorize. What are the units for molar mass? Yep. Grams per mole. Excellent. It's funny because Mark asked the other day whether I was going to have people talk like zombies. When I teach the grade 11s, I ask them, I make a big speech about how math is very good at indoctrinating students. Math's very good at like jamming things into your brain and not have them leave. And I always think of the example of if I were to, now, yeah, I always ask them, if I were to ask you, how do you calculate slope? Some of you might have that answer, boom, all the way already in your head. Does anybody know, how do you calculate slope? There's a little saying, rise over run, rise over run. Have you heard that before? Rise over run. So without even thinking, if a math teacher says, how do you calculate slope? You turn into zombies and you say, rise over run. You don't even think about it. I need you to think that way about the molar mass. So I always get the class to chant like zombies when I ask the question, what are the units for molar mass? Yeah, but I want you to sound more like zombies, like I've indoctrinated you. Grams per mole, right? And so we have fun with it, and it's silly that I didn't get you guys to do that, but that's what Mark was asking. So if you want to participate and have fun, we could do it now. What are the units for molar mass? Oh, look at there. Conrad doesn't know how to make a zombie-sounding voice. That definitely wasn't zombie. Anyway, that's okay. All right. So grams per mole, grams per mole. And that's what's going to tell us our triangle, right? Grams on the top. So when I build the triangle, I like to put the units right into it. Grams and moles. Grams over moles gets you the molar mass. And you know what? It doesn't matter which way that molar mass or that mole sits, whether you've got them that way or not. It doesn't make any difference. Okay? All right. So we know this equation. We know the mole ratio. Let's now put it together and do some examples. Now, don't write down the remember. All right? It says here, remember, if the given information is not in moles, we need to change it into moles using the appropriate mathematical equation. I'm going to help you do this with the maths. All right? So you can write this down, and then we're going to start putting in the information underneath, just like I asked you to do it yesterday. So you can write that down, and you've already done that. Good. Nice job. Yep, just straight to examples. There's no need for words. It's just practice. It's just practice. Yeah, and you don't need to write that because, again, we're going to use our map to guide us. We're going to build a road map. Now, if you're done writing, don't do any thinking yet. Actually, this is good. Don't think right now, Bethany. Don't think. You had a look on your face that you were trying to think. I don't want you to think quite yet. Yesterday, I asked you to imagine that there were two lines underneath the balanced chemical equation. And I said you didn't have to imagine because you all have lined paper. And in the bottom line, I called it the mole line, right? Remember the mole line? And in the mole line, we could move across to find out about other moles using the mole ratio. That's what we did yesterday. And then I told you that the line above was going to be saved for grams information. So now we're ready to use the line above. If I'm writing down some grams that I have in the question, I'll write it just below the symbol. If I know about moles, I'll write it two rows below the symbol. So first, notice it says, find the mass of sodium hydroxide. So I'm going to go to sodium hydroxide, and I don't want to put an X in this case. I'm going to put question mark grams because it's saying find the mass. All right? Produced when 9.7 moles of sodium reacts with water. This says moles. I will put it in the second line, 9.7 moles. All right? Now, from what we learned yesterday, I know how to go from moles of sodium over to X moles of sodium hydroxide. That was yesterday's lesson, and we will do it exactly the same. All right? And what did we call that procedure that we used? Mole ratio. And where do I get the numbers for my mole ratio? This is a review. Where do I get the numbers for my mole ratio? Bethany? The numbers in the balanced chemical equation. Excellent. Perfect. Once we're done that, we're going to take a drive north up to grams. Okay? Now, the way we go from moles to grams is through our molar mass triangle. So right beside that, you're going to put in your triangle. And I know it's pretty, you got a sharper pencil than mine, so mine's going to look ugly. Molar mass is equal to, what's the unit? Yeah, that's great. So what goes on the top? Grams. Nice, you guys are awesome at this. Grams per mole. You're better zombies than my morning class. They're terrible. They're too cool. My grade 11s are so cool. They never want to say anything, and they never want to put their hand up. Annoys me. All right. So once we get moles, we can find a molar mass, and then we can get the grams. All right? So let's do the first part right here, right underneath here. So remember, we go x over 9.7 is equal to, and remember, we go x over 9.7 is equal to 2 over 2. Right? Remember, we just went up 2 over 2. And we do the opposite operation, right? And the 2's cancel each other out, so x is equal to 9.7 moles, as stated by Conrad. 9.7 moles. Excellent. Moles of what? What is this moles of? NaOH. It's right below it. NaOH. I want to find grams. Covering up the grams, right? Grams is equal to molar mass times moles. What do I need the molar mass of? NaOH, because that's what I'm dealing with. So I'm going to have to do a little molar mass calculation off to the side. NaOH 1.0, 16.0, 23.0, I believe, 23.0. And again, I'll get the periodic tables out for those who need one. Oh, we could slide it down. And if you've got a periodic table, then you can kind of help in. What do you mean ignore the coefficients? No, because they're built into the mole ratio. We only worry about the coefficients once, and we worry about it in the mole ratio. I have seen methods of calculating this where you put the molar mass with the coefficients, and then it gets a little hairy and ugly. We don't want to do that. We only use the coefficients once, and we did it in the mole ratio, so we're done using the coefficients. And I believe I get a 40, correct? What's the units? Yes, that's good stuff. That is good stuff. I'm hoping everyone else knows that it's grams per mole too. That's fine. Okay. Molar mass, 40 grams per mole. I'm not picky about seeing units in a calculation. I'm not that picky on it. The moles, 9.7. So what mass of the sodium hydroxide would there be? 388? 388. Conrad, slow it down. There's other people that want to get in on this. 388 grams NaOH. All right? And I like a box put around the answer as the therefore statement. I don't need a, therefore the mass of sodium hydroxide is 388 grams. I don't need that stuff. I don't need a story told. Okay?
So you have to use a ruler to make the box?
No. Please don't use a ruler. If you do, I will deduct marks, because that's just crazy. Okay. Now, I have 4 examples of this, but I'm only going to do 2. Hold on, don't write this down. Do I want to do that one? I want to pick one. Number of moles of produced by, that looks balanced. That's no fun. Oh, let's do this one. Let's do this one. Now notice we only had 2 calculations on this one, and we're only going to have 2 calculations on this as well. And then I'm going to let you work on a few of them that have 2 calculations. Not for a long time, probably about 10 or 15 minutes. Then I'm going to start another little example of one that has all three calculations put together. So I'll make two separate videos, or I could pause. No, I'll probably make two separate videos. If I pause, sometimes I click the wrong thing and I lose the video. Then I'm mad. Oh, we're dealing with sodium hydroxide again. That's fun. So once you've written your balanced chemical equation, try to write the numbers that you're looking for, question mark, whatever, and write the number that you're given, and try to remember to put anything that's grams in the gram line and anything that's moles in the mole line. Find the number of moles of sodium hydroxide. What am I going to write and where to address that situation? Shay, what should I do? That is awesome. X mole on the second line. And I like to use the question mark for grams because we don't use a mole ratio when we're finding grams. And I like to use the X for moles because we're going to use the mole ratio. That's very good. And where am I going to put my, what am I going to put the other information? Alexis, where am I going to put that, that other number? Yep, right here, 1.5, and it's directly underneath it in the gram line. Nice. Now, I do not have any mathematical calculation that can go this way, and I do not have a mathematical calculation that can go this way. I have a calculation that can go this way. So in the up and down, that's the only way I can move is up and down. And it will turn it into moles. That's what it's going to do. So if I'm going to have grams and moles, I need the molar mass again, right? Again, that triangle, molar mass, in this case, grams per mole. And I'm looking for moles, right? So what's my equation going to be? Moles equals grams over molar mass. Grams over molar mass. So we will do that first, and then we will worry about heading that way. All right? So I need a molar mass. So I've got to do that arrow calculation thing. I like to do those calculations off to the side, but I'm going to need space here to do the calculation. So I'm going to do it up here in this space. You'll do it down low somewhere out of the way. But I'm going to calculate the molar mass of this stuff. Oh, actually, I can use this one right here. 16 times 4 sulfur. 32.1? 32.1 times 1. We saw sodium, didn't we? 23.0 times 2. And I'm going to put a funny line off to the side so I can write it off to the side there. That's why I'm trying to see if I can get an answer. Yeah, Conrad, what do you got? 142. Thank you. 142.1 grams per mole. Do we like it? Supporters? Excellent. So moles equal to 1.5 grams divided by 142.1 grams per mole. So how many moles do we have? Come on, you can be Conrad. What do we got? What do we got? Mark? 0.011, did you say? Okay. Mark, because of his advanced knowledge in science, in the sciences, knows to round this answer to what we call significant digits. We round it to the same number of significant digits that is the smallest in the number. You don't have to worry about that. If you were to have something like 0.0106, that would be fine too. You could keep that 0106. Yeah. So don't worry about rounding. But Mark's he's a scientific genius potentially here because he's done so much science. Okay, I'm going to use that moles. Okay, which really puts it right here, 0.011 moles. Now we're going to do our mole ratio, just like we did. Put the x at the top, even though we're going to it, and even though we're heading this way, we're still going to use the same logic. X over this, x over 0.011, that's a 0 by the way, equals, and what over what in this case? What over what? What do you got? 2 over 1. X over this is 2 over 1. 2 over 1. You know what? If you get so good at this, and you know that this is going to come up here, right? And you just take your calculator and go 2 times 0.011 divided by 1 and go straight to x, I'd be okay with that. I don't need to see that step. You know what I mean? If we get so good at it, that's okay. That's all right. It's good to shorten up some stuff sometimes. So what do we have for x? Yeah, Bree? 0.022? 0.022 moles of NaOH. I like that what the substance is at the end, and we figured out how many moles that there could be. So if I start with grams, I've got to head south first using our triangle. Then I can go to moles. If I start with moles like the previous one, I use the mole ratio first. Then I head back up using the molar mass triangle. So we're going to take a little break. I'm going to stop the video, and you guys can then work on the worksheet that is on Google Classroom right now. It's just practice, 1 to 4. And then I'm going to, in about 10 or 15 minutes, do a calculation that starts with grams and ends with grams, does 3 calculations, okay? So I'm going to stop the video.
Is that the second?
That's the second PowerPoint, and it is also then the rest of the worksheet. But I want to make sure that you've got these 2 steps mastered so that we can get the 3rd step, all right? And if you'd like to take a look at the PowerPoint and try those 3 steps, if you've got some of them, and give it a shot, you can go ahead and do that. What do you mean, add another question to it? You mean just go straight up north? I don't want to do that right now. I'm stopping.